So they do not donate anything to the solution, or they do not give something to the solvent. So what happens is just normally the number of equivalents is just 1. So ang ginhimo ko lang sa aton niya exercise is that even though for example you used sodium chloride or salt, the number of equivalent for now is just 2 para uniform kamutanan. Pero I am expecting you to have different answers since you will be using different solutes. So search kada maski ano lang na madumduman mo nga solute, basta makita mo sa balay mo or sa ref mo da gatas, search for your milk is a lactose, right? So search for the chemical formula or molecular formula of your milk. You can get the molecular weight of that, and then you can solve for a 5N solution. Anything para mangin creative ka, and then in laboratories amo lang nihimo ta. So if you have a certain compound, you make a 5N via using kung ano nang number equivalence ya, ano na siyang molecular weight ya. So ano kada mo ang tubig i-add ko in order for me to have this 5N solution. And then eventually, the normality or the values that we use for normality will be also used for you to solve for the molarity, diba, of the compound. And from the molarity value, you will solve also the molality. So this is just review na lang sa inyo concentration of expression and for you to visualize it while doing it. So I think it's kind of given, good guys. Katama. Nga ay, kabalo na ko ni kung pila din tunawon ko, tunaw-tunaw naman ni siya. But I think it would help you to really visualize nga, ay, amo ni siya galing purpose ya. Amo ni siya galing nga kung arat na ko sa laboratory, amo ning amount sang drug kung tunawon sa amo ning nga takadamo sang tubig. So hopefully it could help. And for exercise 5, this will be just all about colligative properties. So let's start with colligative properties. Again, guys, sa mga bag-ulan da sulod, your colligative properties will be under your laboratory. So specifically, this is under your exercise 5. So the lecture for it would be under the solutions, still the PowerPoint under solutions. And let's start. We do have actually 5. Wala pa ko guys ka-present PowerPoint na. Kasi gawa ka lang ko. Oh, wala pa guys. So for this, sorry. Tab. Wala, abi ko wala ano na ko. Pero sige lang guys. Okay, ang briefing pamalan to sang last time. So, okay, slideshow. Okay, so we will begin with your colligative properties. So guys, last time we talked about colligative properties. So anyone who remembered what is colligative properties or what they do represent? So, I mean, when we talk about colligative properties of your different matters, your atom, what are we looking at? Anyone? Anyone? Kadumdum pa kamo sa mga definition ta. I think, ari man ni siya sa Biochem Ligad. Okay, sino to nag-raise hand? Nadula din how? Okay, just please unmute. Do ikaw man to isa nag-raise hand. So who wants to answer, guys? Unmute your mic, please. Oh, okay. Iris. Hello, good morning. So what do we
Good morning,
how do you express your colligative property, or what is colligative property?
Colligative property, miss. Examples of colligative properties are like osmotic pressure or boiling point, and it basically it depends on the amount of solute particles, miss, in a certain solution.
Okay, very good. So when we talk about colligative properties of your compounds or your solutes, amo to siyang pinaka-key point na habal ni Iris. That your colligative property are of course, the properties of your different compounds that depend on the number of your solute present in your solution. Okay? So with this, I think it's kind of hard to visualize at first. Ako guys, sang gatuon lang ko ni sa una. Syempre, given that I have still other subjects, wala na mga napangwakal nga mga lowering of vapor pressure, mga amo ni stuff like that. So we will just have an overview of these different theories, and I'll give you the chance also to calculate it in your on your laboratory nga lab sheet kay para makita nyo mismo ara naman di mga formula sa aton nga lecture. So it's all about substitution again. So you will just be using the molalities, your Celsius. Okay, so we have this four. We have lowering of vapor pressure, boiling point elevation, freezing point depression, and osmotic pressure. So guys, when we talk about lowering of vapor pressure, what comes into mind? Do you have anything that comes into mind when we talk about lowering of vapor pressure? So, magsiling ka guys, vapor pressure, anyone who knows the basic application of your vapor pressure or anything that could produce a lot of vapor pressure? So, anyone? A process that could produce, what process could produce a lot of vapor pressure? What do you think? Ang kadasig tabala maka-procure sa amo ni nga bagay. So, anyone? Wala gida? Anyone? Anyone? Okay. So when we talk about lowering of vapor pressure, or let's establish first. When we talk about gali guys, vapor pressure, so of course this is the pressure above your liquid. Any kind of solution containing liquid phase, solvent, or liquid solute, as long as ga-evaporate sila. So somehow, anything that has a liquid on it would have vapor pressure because at some point, this liquid or this solvents or solutes involved in your solutions would just eventually evaporate. So the evaporation of that or the vaporization of those certain solvents would cause the buildup of your vapor pressure. So we have this thing, the vapor pressure. Okay, overview na ito, danay. Amo na ito, danay, guys. So, any liquid, as long as usually volatile na ang ato nga mga liquid, so magbutang ka lang sang heat. So basically, you're boiling or the one that we are doing always during cooking. So amo ni siya mga processes na mapasaka sang vapor pressure ta. So imagine if you are cooking something or may tubig ka lang guys, maski may tubig ka lang sa baso mo. So during summer, you have water, right? So, ari naman ang aking beautiful nga anak. Okay, so you have water inside your glass. So, as temperature or you just exposed it above your table, and then ara lang da siya. So, nalimtan mo sa imnon, kay gali maginlaktan ka. And then what happens is that, due to the heat, of course, the water will vaporize. So, it is volatile. So, what happens now is the particles will just rise, and then somehow they will form or they will change into, of course, gases. So, ma-vapor sila, literally. Up until that they will build up sa imo di nga area, sa babaw sang imo liquid, thus, the term vapor pressure. So, the more that the solvent is more volatile, of course, guys, mas madamo ang vapor, mas mataas ang pressure. So, amo mo na siya sa pag-cooking nyo, guys. If you do have, nagluto ka adobo. So, if you do have adobo and you have the vinegar, the soy sauce, the water at the same time, and samtang galuto ka, there's an increased vapor pressure sa iya nga atmosphere. So, up until such time nga madula na tanan mo nga vapor, and then they will just dispersed in the air. So, the vapor pressure helps, of course, sa pag-cook man sa inyo nga bagay, di ba? And this is also usually equal man sa pressure nga gina-exert sang inyo liquid below. So, that would be vapor pressure. So, what we are talking about in colligative property is the lowering of your vapor pressure. It means that this kind of property depends on the number of solute. So, it means lowering. So, should you or by adding something non-volatile or a solute sa imo nga water, do you think there will still be an increase of your vapor pressure? Yes or no, anyone? So, di ba, lowering of vapor pressure, this is one of the colligative properties. It means nga gusto ko jutayon ang vapor. So, what should I do? In order for me to have lower vapor pressure in here. So, what should I do, anyone? Anong himuon ko para ma-lower akong vapor pressure? Basing mismo sa definition sa aton colligative property. It is a property that is somehow dependent on the number of my solute. So anyone guys, what should I do? Ano mga dapat ko himuon para mag-lower akong vapor pressure? Okay? So somehow, we will discover that sa inyong laboratory. But of course, given that with the name depending of the number of solute, guys, of course, kung madagdag ko sa akong tubig, for example, this is just pure water, okay, diri na lang ko ma-discuss nga daan kay para kamo na lang di mabasa sa mga discussion sa punta. Okay? So, with the lowering of your vapor pressure, since gusto ko nga hindi ang tubig ko mag-evaporate todo. So, anong himuon ko? Of course, the thing that you should do is to add more solute. Amo na ni siya guys kapos, do kabudlay siya panumdumon. But since si water ko, it is volatile itself, or si acetone mo, napayaran nyo man guro guys, si acetone nyo bala magkuha ka mo sa mga nail polish nyo bala. So it's one of the most volatile solution or solvent also. So what should I do in order for me to lower its vapor pressure? It means that gusto ko hindi siya dasig mag-vaporize. So amo ni siyang ginastoryahan tadi sa lowering of vapor pressure. I would want the solvent or the solution to not be volatile. So what happens now is, in order for you to lower the vapor pressure, you just have to add more solute to the liquid. So by adding more solute, or specifically non-volatile solute, what happens to the interaction? The water and the non-volatile solute will have interaction together. So instead niya ang focus ni water to vaporize lang at normal temperature, for example, mga 28 degrees biga start na vaporize si water mo, or about 32 be. But when you have solute, for example, dugaluto ka lang guys sa balay niya, for example, pochero, di ba mas dasig magbukal, mas dasig mag-vaporize ang water at lower temperature. But if you do add the baboy, the repolyo, and other pagid ni mga ingredient, what happens? The boiling process become more longer, 'di ba? So what happens now is the vaporization of your water becomes longer. So via adding a solute, specifically non-volatile, okay, would have a lowering effect on your vapor pressure. So anything guys, any solution na siya. Okay? So far gets lang man ang amon nga theory. Di ba do kapos naman Miss Ado? Ka-rebels, raise hands, di ba kung gets man lang? So what you should do is just add more solute to it kay para si water hindi siya mag-vaporize dayon. Okay? 'Di ba? Hapos lang, 'di ba ka maalam. Next, we'll move on with your boiling point elevation. When we talk about boiling point elevation, by the term elevation, pila gani usually ang boiling point ni water ta? It is, okay, answer it on your minds. That would be 100 degrees Celsius. So, again, bag-o lang ko naghambal sang lowering of vapor pressure, they are all kind of related, especially these two. Whenever you are cooking or whenever you're going to do it on the laboratory. So guys, since nag-lower si vapor pressure ko because I added too much of my solute, or I added non-volatile solute, of course, at the same time, kay gapakulo gid man ko kay galuto ko be, for example, hello ay sorry gid guys sa graphics ko guys, amo na ning makaya ko, wala man ta gina-bless ni Lord tanan na charot. Okay, so uh this one for example, this is your flame, hello ay gini man, okay, ma-touch up man ta jud, charot di ko gid kaya guys, muna na siya. Okay, so for example, related na siya ang balik ko, if you put a lot of your solute and you are applying your flame, your heat here, what happens is that the water will become quite long to vaporize. At the same time, since dugay siya mag-vaporize, mataas man ang iya boiling point. So, do imagine nyo na lang guys, kung si water lang gid nga pure, it could just boil at about 100 degrees Celsius. So, butang dabi 250 ml ni siyang water. Pero, pagluto ko nga 250 ml of water man gyapon, and I added some of my solute, of course, the boiling point should be about, base, ma-increase siya by 1 point, ma 101 degrees Celsius sa. So, you can see that they are related. So, the more nga damo imo solute, the more nga lowered imo vapor pressure, the more nga you need more heat, diba? As you can see, gin 101 degrees Celsius na siya. You need more heat in order for you to reach boiling point. Okay? So, ang ato na ni guys is that because your vapor pressure should always be equal to your atmospheric pressure in order for you to achieve boiling point. Okay? So, somehow, your boiling point and vapor pressure are always related. So, kung ang isa ga lower, ang isa dapat masaka. Okay? So, hapos lang man siya, guys. Okay lang ta? Okay. So, we'll move on with your freezing point depression. So, with your freezing point depression, guys, by the word, of course, depression, what is the freezing point of water? That would be 0 degrees Celsius. Okay, 0 degrees Celsius. So, balon nyo lang ko guys kung nagawa ka na lang ko isang kung ano-ano ha, basi lost na kamo da. So, freezing point depression, that would be 0 degrees Celsius for water. But since this is depression, it means that you should go lower than 0 degrees Celsius. So of course, guys, I think you can imagine this after the experiment. So hapos na naman niya aton experiment na mini lang gina guys, do kaya nyo lang ginahimuon sa isa ka adlaw. So with your freezing point depression, of course, what do you expect? So who will freeze faster? The water or the one with the solute? Okay, so somehow the one with the solute would have a different freezing point than that of the pure solvent. So hindi ko na pag-ansiran danay because sa laboratory nyo na siya ansiran. Okay, and next we have what we call the osmotic pressure. So your osmotic pressure is just balancing the different solutes sa inyong lawas in order for us to have isotonic nga concentration in order for our cells not to burst and other stuff. Kabalo na ka muna sa osmotic pressure. So, your osmotic pressure always depends on the number of solute. So, kung damo siya, may mo siya hypertonic. Kung normal lang, isotonic. Kung medyo lower than normal, that would be your hypotonic solution. So, this different amount of solutes would give you different kind of solutions. So, amo tong pang-discuss sa biocheman sa una. Nga kung syempre hypertonic ang ibutang mo sa isa ka tawo, so there will be a risk of cell lysis. Kung hypotonic naman, there will be cell shrinkage. On the other hand, the hypotonic could cause cell swelling. Okay, so mga amo na siya nga mga concept. So, what else? I think I'll be showing you the formula for this different colligative properties. And also guys, trivia ba? Grabe. Kaya para magamit nyo ni siya para kay laboratory ni siya. So, amot lang, if do you read recipes for making ice cream? May ara ka muna ang mga labasahan, like sa all recipes or sa mga Facebook lang ah. So, make your own dirty ice cream. Try nyo bala search. Ambot lang ko may sa aton ink guro guys, may ara ko that link sang making sang ice cream or may trivia na da. So, usually, when we make ice cream before, ang what we do is to actually dumdum ako ni isang high school, naghimo kami. Kahit sa City High, kasi ng mga taga City High, so una, so sa mga, basi may nag-spec side as inyo, basi alumni, taka mo. So, what we did sa amon nga laboratory, so una, is that we made ice cream. So, that was just, dumasta na slay cream lang to siya, guys. Tapos gimbate namon, butangan flavor, and stuff like that. But this is the application for colligative property. Ang natabo is that when you make ice cream, hasta subong, you can use that one. So you put the cream and everything sa inyo nga container. And what you should do is not just, if you want to really make a good ice cream, ang iya bala pagka-freeze na bala nga do ka tiga-tiga agad, and you just have an ordinary refrigerator, what you should do is to put the container containing the ice cream mixture, and then, pag ka mo sa mas bigger nga, do open lang nga container, and then you put the ice, and then, you sprinkle salt around it. Okay? So nga amis nga ginahimo na siya. So I think you can search after this sa Google how to make dirty ice cream or why do you put salt when making ice cream. So hindi salt ya guys sa sulod sa ice cream but the ones surrounding your ice cream. So kita nyo man guro mga mamang solbitero that usually yung mga gahimot na dirty ice cream. So I think some of you sees them that they are sprinkling salt around the ice. So the principle behind that would be the colligative property via the freezing point depression. So by the word freezing point depression, what do you think? Di ba si ice mo, it is a pure solvent of water. So you have to expect that if you put salt on it, what happens? Of course, you would need a lot of freezing energy para ma-freeze mo na ang ice plus salt. So, hindi, kung si ice lang yan, at 100 degrees, kaya ko na siya i-freeze. But by adding my salt to that ice na nag-surround sa akong ice cream, tapos i-freeze ko pa siya, your solution would require about, di mo siya ay, kagin-ada niya ko damo-damo nga salt, mga 5 tablespoon of salt. May nag-drop ang imo temperature sa -10 Celsius. So, matabo, si freezer mo mahambal nga, ay, hindi talaga niya kaya yung ato niya nga solution ni, nga mixture ni, hindi talaga niya siya mapatiga at 0 degrees because hindi na siya pure lang nga ice. So, mas damo pa sang kinanlan, patig-ahon. Diba? So, mas kinanlan ta, ma-lower ang temperature mismo or we need to reach -10 degrees Celsius in order for us to have this beautiful ice cream nga mixture. So I think guys, you can, gusto ko siya tani ipa-experiment kasi it's quite costly kung ang ice cream pa kamo tapos kauno niyo mo lang gyapon. But you can do this at home, make your own ice cream, put ice, put salt, and the other one, hindi niyo ipagbutangan salt. So lang tawon niyo kung sinong mas tiga after. Okay, so that would be it for the trivia. So usually we add salt in order for us to lower more the freezing point. Para mas tugnaw, para mas dako nga katugnawon ang kinlanlanta. Okay? So far, gets lang man ang amo na nga concept sa aton nga colligative properties. Okay, miss? Kaya na. Okay. So these are the different concepts. So you just read on it. Ang mga different nga concepts. Amo naman ni siya pinanghambal ko tanan, guys. So in order for you to, may harap mo lang guys drawing, di kag diagram. Okay. So this is the water, this is the one with the non-volatile solute. So as you can see, mas jutay ang mga galutaw nga vapor. And also we have calculations under it. So with the vapor lowering or when we talk about vapor pressure, we are just using what we call the Raoult's law. Okay? So this is just the formula, guys. And when you look at it, this is just the mole of your solvent. So if you want to get the vapor pressure of the solvent, it means that in this kind of solution, we are just going to get the vapor pressure of your water since specifying a solvent. Okay, so we are using the Raoult's law. So with this one, we are just getting the moles of your solvent and your solute. So it's substitution. You did this already with your Dalton's law of pressure. So try to calculate it sa aton nga laboratory. Times the pressure mismo sang aton nga solvent. And this is the sample problem. So this is under your laboratory. So please try to answer. And always remember that your water has a specific gravity of 1. So whenever you want to convert your water into grams, you should always remember that the specific gravity is equal to 1. So di ba gintudloan ta nakamuligad how to convert a solvent in ml into its mass equivalent or gram equivalent via your specific gravity. So just treat your specific gravity as density, okay? Because your water is always equal to 1, the specific gravity. So we'll move on. We have also the formula for boiling point elevation. So with this one, what we are after for your boiling point elevation is your different constants. So learn about your different constants such as your ebullioscopic constant when you look at your manual. So karon nyo na lang to lantawon. And by the time that you would be needing formula to solve, these two formula will come in handy. So this is the change in your temperature or boiling temperature. So it means that usually the normal temperature for your water would be, or the original would be, pila guys? Sorry. The the one that we are referring to would always be the 100 degrees Celsius. Okay? So since this is the change in your boiling point, change in your boiling point is equal to the ebullioscopic that you'll be seeing sa inyong laboratory times the molality of your solution itself. So you will be getting the change in, for example, nag-multiply na ako sa ebullioscopic constant ko. Ang balong ko na lang gani, ara man to sa inyo lecture. That would be 0.51 Celsius per molal. May ara ako solution na about 2 molal. So of course, multiply ko naman na sila diretso. That would be 0.51 times 2. That would be about 1 point. Change in boiling point would be about 1.02 Celsius usually. So of course, the resulting boiling point that you will have would of course be, so the new boiling point temperature would be equal to now, how much? That would be plus, 100 degrees Celsius plus 1.02 degrees Celsius. And this will be the new boiling point natin sa aton solution. So you will have about 101.02 degrees Celsius. So doon mo lang na siya ang magwa sa aton nga calculation sa aton laboratory. So you will first calculate the change via using the constant and pila ang moles ang imong solution mismo. And via this one, you will just refer it to 100 degrees Celsius. Since this is boiling point elevation, you will just add the change in your boiling point elevation to your 100 degrees Celsius. Or if gina-indicate nila nga hindi water, guys, kumahatag sila ba, the boiling point of your acetic acid is 97.2. So of course, you will add it to the 97.2, depending on the solvent that we are talking about. Raise your hands if you get what I mean with this one, with this concept. Raise hands. Gets lang, guys? Okay. So we'll move on. Okay. We'll have also your freezing point depression. So same to that of your boiling point elevation. With your freezing point depression, guys, ang matabo, of course, the standard would be your 0 degrees Celsius or any compound that is being specified on the problem. But usually, what we are referring to would always be water having the 0 degree Celsius. So in this one, what we are having is the constant, or what we call the freezing point depression constant. So this has an amount of about 1.86 Celsius per molal. So usually this is the one that you should always memorize, the 1.86 and the 0.51. Nagwa gani siya, guys, sa board exam, don't worry. Nagwa gani siya ya. So, doon mo ni mga part nga pala mugnaw na ko, manag-ubos ng ako niya sugar, manag-ugto na. Tapos may mga gahakita ka mga KF, di ba? Do ka buiset, charot. Okay, so kaya nyo na. So 1.86 Celsius per molal. So again, use calculate for the change in freezing point depression. So of course, if you already have the freezing point, okay, if you do already have the change in freezing point, you just, so kung may ara na ko change in TF ko, ang resulting temperature ko mismo, minus ang ako ni TO, so gin-transpose tala ni siya in order for you to have the 0 degrees Celsius, since this is our standard, minus, of course, ang change ang imo TF. Diba? Muna na siyang matabo. So the resulting temperature now would be, so for example, si 1.86 ko, gin-multiply ko siya sa 3 molal. Okay? Nga solution. So 1.86 times 3 molal. So may about 5.58 ka nga change na natabo. So of course, your 5.58 degrees Celsius is the change. So since this is depression, you will minus it. You will subtract it to the 0 degrees Celsius of your water. So of course, the resulting freezing point now, because nag-add ka, imagine mo, ang 3 molal ko nga solvent will become, or will freeze at negative 5.58 degrees Celsius. So kung si water lang niya, kaya yan niya magtigas sa 0 degrees Celsius. But si 3 molal ko yan mismo, nga solution, it means may other na ko da nga solute, nga ginbutang para mag 3 molal siya. Kinanlan to yan negative 5.58 nga temperature para magtigasa. Diba? Hapos lang. So, we'll move on. So, somehow the nasaan na? 8:40. Okay. So, somehow your freezing point, this is the application sa aton body. So, trivia again, all of our bodily fluids freezes at about 0.52 degrees Celsius, negative 0.52 degrees Celsius. It means nga ang aton dugo, aton luha, aton aqueous humor, aton cerebral fluid, when you put them on the refrigerator, they will freeze at about negative 0.52 degrees Celsius. So, kung imo ref, ang kaya lang ihatag is about 0 degrees Celsius. So, hindi magtiga ang aton bodily fluids. Okay? So, basically, if the certain fluids, so, kumbaga guys, sila ang aton measure or standard for isotonicity. Okay? Do know that your blood, your aqueous humor, the different bodies in our body, the different fluids in our body are all isotonic. Okay? It means that isotonic sila, wala sila ga-cause ang any change sa aton cell, wala sila ga-cause ang more solute or more water to get in or out of our cell. So what happens is that they are isotonic, and basically, kung isotonic ako, no, usually magtakos sila, negative 0.52 gid ang aton niya freezing point. So kung ang certain liquid wala siya yan nagtiga at negative 0.52 tapos tawo kabigin ko anta ka sang certain liquid, syempre hindi ka tawo ko no. Kaya dapat isotonic na siya. Or maybe there's a problem with your base may diabetes ka, base mas taas imo potassium, therefore medyo lain na ni siyang isotonicity sa aton blood. But if normal lang man tanan mga laboratory, ang aton different nga mga bodily fluids ga freeze at this point. So if you would want to make a certain isotonic solution, application ini sa. Sorry ho. So if you would want to make injections and eye drops, okay? So, syempre guys, calculate gina siya sa laboratory. But one of the testing after that would be the freezing point depression. So, if ang eye drop na ginhimo ko, gin-measure ko siya at 3 normal, at amo ni, ala, sige, isotonic na ni siya guro, compared sa aton lawas. Okay? Compared sa luha ni amo na B. Okay? So, dapat, ang ginhimo ko nga eye drop, it should also freeze at about negative 0.52. Para makonclude mo nga, isotonic ang ini nga solusyon. So, basically, pagid guys, si NSS ta, di ba? NSS, your dextrose, tanan nga gina-inject sa inyo guys, usually isotonic gina sila. Okay? Kaya para gani hindi mag-cell lysis, hindi mag-cell swelling. So, kanday NSS ni, they should be isotonic and technically, they should also freeze at about negative 0.52 degrees Celsius. Kaya kumbaga, this is your reference. So, kung si NSS ko nag-freeze na siya at about 0 degrees Celsius, it means na hindi ni siya NSS. It means hindi ni siya isotonic. It means hindi ko ni siya dapat iturok sa pasyente. So, are we clear with this concept? Kung ginastoryahan ta ni siya sa physical pharmacy. Okay? Kaya para mag-pharmacist ka, so uli, hala, nga nag-freeze na ni siya una. So, of course, maybe there's something wrong with the formulation kaya nga dapat negative 0.52 ang aton gina-after. Okay? So, dapat at 0.9% of your NSS, this is our normal isotonic solution, dapat siya ni mismo ma-freeze at negative 0.52 degrees Celsius. Are we clear with that? Raise hands, everyone, if we're clear with this theory, kung paano siya gina-relate sa aton lawas, sa aton mga different mga dosage form. Okay, okay na? Raise hands, raise hands. Okay, basi lost pa ng iban. So do not hesitate to ask. Okay, muna naman na siya guys. Okay, move on. Hala, may calculation na i-reason ko to. Charot. Okay, so you can refer to this one for the calculation. So what else? We have also the osmotic pressure. For the osmotic pressure, so that's the definition of it. But somehow, hypotonic, isotonic, hypertonic, manigapon na pang storyahan ta. So the more nga damo solute, hypertonic, and stuff like that. So this is our formula. So pi, Payag gid itsura, no? So this is osmotic pressure is equal to MRT. Way ko gini siya guys nalipatan kay MRT, do ka budlay ilipatan sa MRT nga term, di ba? So the I here is what we call the Van 't Hoff factor. It means that this is the number of dissociated ions in your solution. So basically, this kind of formula is used for electrolytes. Okay? So kung, for example, sodium chloride, your sodium and your chloride dissociates in your water. Therefore, you have two ions or you do have two Van 't Hoff factor. But sa aton niya guys nga experiment or somehow sa board exam, ginakakas ni nilang I. So wala naman na sila gapangayo. Ang ginapangayo lang nila is the pi gid siya. Your osmotic pressure is equal to MRT. Okay? So okay na siya guys, mas hindi ta magamit sang I. Okay? So this is still related. The R is still the same to that of your gas law because it still talks about the pressure. So, discover nyo lang da karon sa mga given nyo kung anong mga dapat usaron. So, molarity of the solution, you do know how to get the molarity already, and the temperature should be, since si R tara sa Kelvin, do not forget to convert into Kelvin. Okay? So, that would be it for our colligative properties. So, may ara tada mga formula and other stuff. So, tanani nga mga questions sa aton nga PowerPoint, gimutan ko na lang siya sa laboratory. So, in order for you to digest the topics. Okay, so we're done with laboratory. Discard. Okay, so we'll have 5 minutes break. So, take